Hello everyone, I am Maria Merlino. I am a researcher in food science and technologies at the University of Messina in Italy, and today I will talk about our research on the stability assessment of traditional and lactose-free pasta filata cheese during the shelf life. The quality of most foods and beverages decrease with storage or holding time. The Institute of Food Technologists in the USA has defined shelf life as the period between the manufacture and the retail purchase of a food product during which the product is in a state of satisfactory quality in terms of nutritional value, taste, texture, and appearance. Shelf life studies are an essential part of food product development for food industries. Establishing a proper shelf life avoids food waste and guarantees the quality and safety of a food product. The consumer can only judge the quality of the product at the time of purchase. Thus, the shelf life refers to the time for which food can remain on both the retailer's and consumer's shelf before it becomes unacceptable. The shelf life is influenced by several factors such as chemical composition, processing, packaging, and storage conditions. Chemical, physical, and microbiological parameters are commonly used to determine the shelf life of food products. Mozzarella cheese is a worldwide known traditional Italian pasta filata cheese mainly produced with cow milk. Based on the moisture content, two different types of mozzarella cheese can be defined. Low moisture mozzarella, typically used for cooking procedures such as dressing pizza. High moisture mozzarella is mainly used as a table cheese. High moisture is particularly appreciated for its freshness and fresh milk flavors, and it remains one of the most consumed dairy products. Mozzarella is usually packaged in brine to preserve the freshness characteristics during the shelf life. In this condition, there is an increased probability of deterioration in terms of microbial growth, chemical reaction, and mass transfer between the product and the preserving liquid, leading to the generation of flowers, chromatic alteration, and change in the structure. Since lactose intolerance affects about 75% of the world population with different distribution from country to country, many dairy companies produce lactose-free products which are now widely present on the market. Nowadays, free lactose dairy products represent a class of food products increasing in use and popularity in the last years. Only between 2017 and 2022, a growth rate of more than 7% per year was observed. The shelf life of high moisture mozzarella, including the lactose-free one, commonly range from 1 to 2 weeks. The shelf life extension of mozzarella cheese is a subject of great interest, and recently it has been largely investigated due to the high foreign demand and the increased exports. However, very little is known about the stability of lactose-free products, and no research has been performed on lactose-free mozzarella cheese. Some researchers suggest that lactose-free products are more likely to undergo to Maillard reaction due to the presence of a higher amount of reducing sugars and an increased level of free amino acids than a lactose content product. In this context, the heat treatments may be responsible for quality problems due to the formation of compounds such as furazine, hydroxymethylfurfural, and other Maillard reaction compounds. Microbiological and sensory parameters are generally used to define the shelf life of mozzarella cheese. However, no research has taken into account the aroma volatile compounds for the shelf life monitoring of mozzarella cheese, as usual for other types of cheese. In this context, this study aimed to verify the importance of volatile compounds and sensory features in the shelf life definition of traditional mozzarella and lactose-free mozzarella cheese. Traditional and lactose-free mozzarella cheese samples were produced by a local dairy industry using the following cheese-making process, starting from the same standardized cow's milk. Milk was acidified by a mineral acid and coagulated using a liquid rennet. Both mozzarella types were mechanically stretched in hot water, molded, and then cooled in unsalted water, and finally individually packaged in polyethylene plastic bags with a preservation liquid made from potable water, calcium chloride, and sodium chloride. Only for lactose-free mozzarella cheese, commercial lactase was added to the milk after pasteurization for the enzymatic hydrolysis of lactose. Production was repeated 3 times on 3 different days. All the samples were refrigerated storage for all the shelf life and analyzed at 5 different storage time, at the production time and after 4, 8, 13 and 20 days. At any set time, volatile and sensory analysis were carried out in triplicate within the same day. Volatile aroma compound extraction was performed by the headspace solid phase microextraction technique. In particular, a 40 ml vial was filled with 10 grams of each chopped and homogenized sample and 10 ml of a saturated sodium chloride solution. The sample was equilibrated for 20 minutes at 40 degrees and then extracted for 30 minutes. During the extraction, the sample was continuously stirred. The desorption of the analyte was performed at 260 degrees in the splitless injector of the GC-MS. Volatile compounds were analyzed by using a Shimadzu GC gas chromatograph directly interfaced with a triple quadrupole mass spectrometer. A polar 60-meter column has been used for the separation of the analytes using the condition here reported. Compound identification was performed using mass spectral data, linear retention index, literature data, and injection of standards, whereas for quantification the method of the standard addition was used. Quantitation was based on a 5-point calibration curve generated by plotting detector response versus the amount spiked of each standard. A qualitative descriptive sensory analysis was performed in a sensory laboratory using a trained sensory panel recruited among the students of the Department of Veterinary Science at the University of Messina. The assessors were selected among who habitually consumed mozzarella cheese and trained with traditional and lactose-free mozzarella cheeses of different brands. A list of attributes and their definition were developed and here reported. The descriptors were quantified using a 9-point intensity scale, where 1 was non-perceptible and 9 strongly perceptible. The results were expressed as the average of each sensory attribute. Data were statistically analyzed using a Excel state software. ANOVA and PCA were applied to volatile data. 54 volatile compounds have been identified in the traditional and lactose-free mozzarella cheeses belonging to the following classes of substances: ketones, aldehyde, alcohols, esters, acids, terpenes, lactones, and hydrocarbons. Qualitative differences were found between the two types of mozzarella cheeses. Traditional mozzarella was characterized by a higher amount of aldehydes and alcohol, whereas lactose-free mozzarella was characterized by a higher concentration of ketones, esters, and acids. Here the qualitative differences between the two types of cheese are shown. Most of the identified compounds were present in both types of mozzarella and are here reported. Other compounds were found only in traditional sample and shown here in blue, and others only in lactose-free mozzarella sample shown in red. These two graphs show the amount of volatiles with statistical significant differences during the shelf life between the samples. 2-heptanone and acetoin were the highest compounds in both types of mozzarella at the beginning of the shelf life. At the end of the shelf life, ethanol, acetic acid, and octanoic acid prevail in both types, whereas 3-methyl-1-butanol increases only in lactose-free samples. Statistical principal component analysis of the data helped us to better understand the differences among samples. The PC2 is allowed to separate compounds according to the presence or absence of lactose. Sample until day 13 and day 8 for traditional and lactose-free mozzarella respectively results well grouped. The compounds that most influenced the separation of these samples were 2-heptanone and acetoin, the main compounds responsible for fresh cheese aroma, that arising from beta oxidation of saturated fatty acids and citrate metabolism of lactic acid bacteria. Acetoin is the main ketone in mozzarella and is characterized by buttery and woody sensory notes. Due to the collateral proteolytic activity of the enzyme used, compounds from aminoacidic metabolism such as leucine and phenylalanine, related to negative descriptors like rancid and bitter, characterize lactose-free samples from day 13 to day 20. Moreover, lactones were identified here for the first time in mozzarella cheese, and their presence was much higher in the lactose-free samples. They arise mainly from lipolytic activity on hydroxylated free fatty acids. Finally, compounds arising from lactose metabolism influence the separation of traditional sample after 20 days of shelf life. The main of them arise from the bacteria spoilage, such as coliforms and Pseudomonas or psychotrophic bacteria, and bacteria metabolism of acetoin and 2-heptanone present at the beginning of the shelf life. As regards the results of sensory descriptive analysis for traditional lactose-free mozzarella cheese during the shelf life, statistical significant variation occurred during the shelf life of both cheese types for all the sensory descriptors evaluated by the panel. Moreover, traditional lactose-free mozzarella cheese differed concerning yogurt odor, bitter and salty taste, elasticity, and juiciness. The figure shown here reflects the separation achieved using the sensory scores. Traditional mozzarella cheese samples from 0 to 13 storage days and lactose-free mozzarella cheese samples from 0 to 8 days were grouped on the positive side of PC1 with about 73.25% of variability, indicating sensory stability of the two products until this time. Sensory descriptors which most influenced this separation were as with taste, white color, firmness, juiciness, and gumminess for lactose-free mozzarella cheese, milk flavor, milk odor, elasticity, cohesiveness, and smooth surface for traditional mozzarella. All these descriptors are associated with positive sensory characteristics of fresh cheese products. Traditional mozzarella cheese after 20 days were separated from the others and characterized by a salty and bitter taste, whereas lactose-free mozzarella cheese from 13 days to 20 days samples were on the negative side of PC1 and PC2, characterized by the negative descriptors of butter odor, yogurt odor, acid taste, and bitter taste. The bitter taste of lactose-free mozzarella cheese could be associated with the release of bitter-tasting peptides produced by the proteolytic activity of spoilage microorganism or the lactase enzyme. A correlation between aroma volatile compounds and odor and flavor descriptors shows how the samples from 0 to 8 days are characterized by a higher content of acetoin, mainly associated with milk odor and flavor, typical sensory properties of fresh mozzarella cheese. As the storage time increased, the levels of compounds associated with fatty acid and amino acid metabolism increased too, such as benzaldehyde and delta-octalactone related to the yogurt odor, and 3-methyl-1-butanol and gamma-dodekalactone correlated with butter odor. So, as regards traditional mozzarella and lactose-free mozzarella cheese samples, the producer established a shelf life of 20 days at refrigerated conditions based on their microbiological stability. Data here obtained indicate that during the shelf life, the volatile profile of traditional mozzarella and lactose-free mozzarella significantly changed. An increase in the amount of the aroma compounds coming from amino acid and fatty acid metabolism occurred in the lactose-free mozzarella samples after 8 days of storage and, to a lesser extent, in traditional mozzarella cheese after 13 days of storage, respectively. This resulted in a sensory decay perceived by the panel, which assigned lower score values to positive descriptors associated with fresh cheese products and higher score values to the negative ones at the end of the shelf life. In conclusion, this study highlights the importance of considering the volatile aroma profile and the sensory quality of mozzarella cheese for its shelf life definition. Moreover, despite the microbiological stability, a shorter shelf life should be established for lactose-free mozzarella than traditional mozzarella cheese. Thank you for your attention.